Dear students, Jai Hind, very good morning. Welcome back. I would not utilize the word revision lecture, but in today's lecture, we are going to target some of the practice for the chapter 10, light, reflection, and refraction. No doubt, as per the board design, and as we got the list of the topic, few topics were already excluded. Understand, from your regular routine course. But during the explanation of this particular chapter, if you can remember, way back, I think almost 5 months back, so at least we want to again, because these chapters are a part of not only your NTSC exam, but at the same time it is also part of our semester 1 evaluation program. So we need to just have a practice of some of the numericals regarding spherical mirror. There are no numerical regarding plane mirror in your regular curriculum. Okay. So today, dear student, we are trying to solve some of the numerical based on spherical mirror. Okay. Now, dear student, before we start today's lecture, I want to share some important points with you before we start. Practice examples. Okay. So today it's you can consider chapter 10, as you know, light. Okay. Reflection and refraction. Okay. Today, dear student, in our lecture number 1, I need to mention revision. Understand? Because we are going to solve some of the numericals. Okay. Now, before we go for numericals, I want to discuss some of the MCQ related topic with you. Dear student, as far as spherical mirror are concerned, curved mirror are concerned, concave and convex mirror, understand some of the important basics which every student has to keep in mind whenever they solve any example regarding spherical mirror. Some of the important points which you should keep in mind. Understand? Let us just take an example. Suppose if it is concave mirror, okay? If it is concave mirror, you should have to note down very important point. For concave mirror, as you all know focal length is always negative. These are some of the points you need to keep in mind whenever you solve any example regarding concave mirror. Focal length has to be compulsorily taken negative for concave mirror. But if it is convex mirror, focal length is always to be taken positive. Some of the important aspects, some of the basic point which you need to remember when you solve any numerical regarding spherical mirror, curved mirror. For concave length, focal length is always negative. For convex lens, focal length is always positive. These two important points, not only this, one another important point I need to mention to you is any mirror, either it can be concave mirror or convex mirror, whatever, this is always negative. Please remember, object distance u is always negative. Some of the important points you need to note down when you solve any numerical, and this fact, object distance is always negative, that is also reconfirmed by sign convention of spherical mirror. Object is always kept on the left side of the mirror, so it is going to be negative. Remember, dear student, these are some of the very important points going to help you. And one more thing, dear student, image distance means where the image is formed. Understand? So, dear student, remember one thing very clearly. Image distance may turn out positive, may turn out negative. Remember this point very clearly, because that is going to help you a lot in solving the examples. Image distance means, distance between mirror, pole of the mirror and the image. Okay? Image distance while you solve any example may turn out to be positive, may turn out to be negative also. Now remember, dear student, whenever image distance turns out positive, this gives you an idea regarding the position of the image. If image distance is positive, then image is formed behind the mirror. Please note down this word. I have just written behind. Image distance positive. Image is behind the mirror. Remember, and dear student, if image distance is negative, image is in front of the mirror. These are some of the important aspects in solving any particular example we are discussing. Still, I am going to discuss some more also, but first let us have a sum up of this. For concave mirror, focal length is always negative. For convex mirror, focal length is always positive. Object distance in either of the mirror, whether concave or convex, going to be negative. Image distance, dear student, may it be asked in example where the image is formed. So whenever you find V, image distance, if it turns out positive, that means image is formed behind the mirror, whatever the mirror it can be, concave or convex. And if image distance is negative, image is formed in front of the mirror, ahead of the mirror, to be more precise and specific. Is it clear in your mind? Some of the important MCQ can be designed from this, dear student. Maybe in NTSC they can in NTSC actually what I have seen in phase 1, they are trying to just the MCQs in NTSC stage 1, this is going to be useful to you in that also, are designed in such a way that they are actually trying to check your memorization skill, at the same time your concept clarity of the topic. A student needs to be very sure that for concave mirror focal length is always negative, for convex mirror focal length is always positive, object distance is always taken negative. If image distance is positive, then image is formed behind the mirror. If image distance is negative, image is formed in front of the mirror. Suppose, dear student, I design MCQ in this way. Suppose I ask, suppose my first question, suppose I ask this way, for, just note down this, for spherical mirror, I am not mentioning any particular, okay? I am just writing for spherical mirror, okay? If I write for spherical mirror, image distance, just note down, image distance is minus 6.5 centimeters. Suppose this is given, dear student, and you are asked the position of image. Any MCQ can be designed, understand, is dash. MCQ can be made simple way, understand. For preparing the MCQ, you do not have to explore more and more reference book. No doubt exploring the reference book is going to give you some of the mechanism of designing any particular question, but here such a simple question to test your basics. Image distance is written minus 6.5 centimeter. Can you guess where the image is formed? Obviously, when you are conceptually sound, that image distance negative, that means the image is formed in front of the mirror. Okay, so what can be your answer to this? Image is formed at a distance of 6.5 centimeter ahead of the mirror in front of the mirror. So this way, simple looking MCQ can be designed, but when you are conceptually very strong, you can answer such question very easily, dear students. So you need to be very conscious regarding this. Understand? Here I just make a minor change, that for spherical mirror, suppose I write image distance, understand, is 2.5 centimeter. The position of image, so obviously when the image distance is positive, image will be formed behind the mirror. Okay, so what you can write in answer to this? Image is formed at a distance of 2.5 centimeter behind the mirror. So this way, dear student, when you solve any MCQ or numerical, your conceptual basic needs to be very strong. You have to be very sure regarding this, because when you solve example, we are going to solve few example, this is going to be tested. At that time, uh, if you are conceptually not strong, that V positive means where the image, V negative means where the image, understand? Then after finding V, you will always remain confused what to write, behind the mirror or in front of the mirror. So you need to check this basics clear. Few more basics, dear student, we want to discuss are this. Regarding, I'm just writing it here, regarding these are clear points. Okay. Regarding, let us take some important aspect, magnification. Okay. You by symbol know what is magnification M. I think if I can remember during the explanation of this particular lecture, this particular chapter, I have, if I can remember, discussed some of the MCQ maybe regarding magnification, but it happened, I think, almost in April. So April or May, so uh, I think almost 5 months, 4 or 5 months, many concepts may have gone out of your mind. That's why we actually declared revisional tests so that you can revise those topics again and again. Understand? Regarding magnification, you need to remember few important points which I want to discuss with you. Okay, dear student, magnification M. Now, one very important thing, an MCQ also needs to be learned, understand thoroughly, dear student, by understanding the concept. Magnification can turn out positive or negative, as you know. Magnification can be positive, can be negative. Now, dear student, if magnification is positive, what you can say regarding nature of the image? This is what we want to first discuss. Nature of image. because in question every now and then you are looking for this word. Find position, nature, and the size of the image. I want to bifurcate all three words conceptually. Nature. Try to understand, dear student. Nature means either the image can be real or virtual. Two object only, either virtual or virtual or real. Now, dear student, if magnification is positive, when you solve the example and if you get m positive, that means, dear student, relate the value of magnification with nature virtual. And when you say virtual, obviously erect, virtual cannot be inverted. So this is clear in your mind. Magnification positive, that means image is virtual and erect. This is fixed. Any here MCQ can be designed if I give any value of magnification, but if I give it positive and I ask you what could be the nature of the image, in option they may give you some manipulation of the option, but one is the correct option. Magnification positive means image is virtual and erect. Remember very clearly regarding this. Understood? Magnification negative means image is real. Real, obviously, always inverted. Remember this thing, dear student. We are going to discuss at least 5 to 6 MCQ just from the value of magnification. Understood? One thing is clear, magnification positive means image is virtual and erect. Magnification negative means image is real and inverted. Okay, these concepts, dear student, I have spoken three words. Understood? Which were those three words I just mentioned? I mentioned one word, position of image, that you can ascertain from image distance. Then I spoke one another word, nature of the image, so that you can guess from the value of magnification, dear student. Understood? And then remains size of the image, so that you can find, after you find the value of magnification, size of the image can be easily calculated. Is it clear in your mind? Before we go for solving examples, this actually at that time I have explained already this, but may went out of mind in this due course of time. That's why I just want to share those concepts again with you, and we want to take few revision lectures for solving examples of chapter 10, reflection and refraction. Import. Today we are targeting only mirrors that you all know. Concave mirror, focal length is always negative. Convex mirror, focal length is always positive. Object distance, either mirror it can be concave or convex, always negative. Next, image distance. If image distance is positive, image is formed behind the mirror. If image distance is negative, image is formed in front of the mirror, ahead of the mirror. Next, nature. Value of V always gives you an idea regarding image position. And my dear student, I still here also one clue point I can share with you. V positive, that means image is behind the mirror, and whenever, dear student, mark this point, you get image behind the mirror, it is always virtual, and virtual obviously erect. This is also one of the clue point I can share with you. From magnification, no doubt, we can guess the nature of the image obviously, but we also gives you an idea whenever image is formed behind the mirror, it is always virtual. Remember. So if V positive, you can guess the nature. Image is virtual erect. Understand? And if V negative, obviously what you can guess, can you tell me if V negative, then the image is real and inverted. No doubt this is one way of guessing the nature of the image just by looking and concentrating on the value of V. V positive, image behind the mirror, because it is behind the mirror, virtual and erect. V negative, image in front of the mirror, because it is in front of the mirror, it is always real and inverted compulsorily. From magnification positive, image is virtual and erect. Magnification negative, image is obviously real and inverted. Understood? Now, dear student, if we want to discuss some of the MCQs regarding only the value of magnification, how can they be designed only from magnification? Suppose let us discuss some of the MCQs. Okay, suppose, dear student, the first one, if m equal to plus 1, I am not going to write the complete MCQ. I am just going to discuss with you. If m equal to positive 1, I am just putting this. That means you have to guess for me nature and the size of the image. because I have already, at that time I told you that size can be decided from the value of the magnification. That is clear in your mind. I have already mentioned not only sign of the magnification but value also. M equal to plus 1. See, try to clear your basic. Plus means virtual and erect. 1 means size of the image, understand, is same as the object size. Why, dear student? So you know the formula. Who can remember the formula of magnification? What is that? H dash upon H. This represent image height, this represent object height. So both are suppose 6 6. Answer is going to be plus 1. So dear student, is it clear in your mind? If m equal to plus 1, guess the nature and size of the image. It is virtual erect, plus sign, virtual erect. 1 means of same size. I can twist the MCQ, dear student, if I speak. This is called the applied MCQ. You know M equal to plus 1 means image is virtual, erect, and of same size. I am speaking the MCQ in twisted way. I am speaking if the image is virtual, erect, and of same size, what could be the value of the magnification? Obviously, plus 1. This is nothing but the concept clarity and the check of your basics. What is that? Applied when we utilize and speak those words, that applied MCQ can be the part of the board exam. We mean to say that whenever you prepare any topic, you need to be very, very sure and strong about your concept. Understand, if you are conceptually, basically, you are very stronger. Understand, that's very important for you. Okay? Now, one more. Suppose I write this way. If m equal to minus 1. Now, any of you can guess and write before me. M equal to negative 1. Can you guess? What could be the nature and size of the image? Negative. Tarat, concept needs to be very clear. Negative, real, inverted, 1, same size, dear student. Very clear in your mind. One more thing also I want to share. Do you know which is the mirror which gives virtual erect image with magnification plus 1? If you can remember, only one mirror, that is plane mirror. I can ask in MCQ this way also, that from which mirror value of m is always plus 1. So for plane mirror only, m equal to negative 1. That means image is real, inverted, and of same size. Which mirror can produce real, inverted image of the same size of an object? If you can gather all image diagrams in your mind, this is possible only by concave mirror. So these are some concept clarity, dear student. You have to be very sure when any MCQ appears in front of you, you need to be very strong about your basic concept. Understand, I have seen students when they are not stronger in their basics, then and then you have to look here and there and try to just catch the data of the sum. If you are conceptually stronger, understand any example asked, you may be able to solve it very clearly. Okay. Two MCQs we discussed regarding magnification. M plus 1 image is virtual, erect, and of same size. Which mirror can produce such type of only image? Only plane mirror. Magnification minus 1. Can you guess the nature and size? Real, inverted, of same size. Which mirror can produce such type of image? Only concave mirror. Okay, let us discuss some other MCQs. Okay, third one, note down this. If m equal to if m equal to plus 1.7, what is the type of the image and which mirror can do this? Plane, concave or convex? Just guess in half minute only. Just guess. I have already written m equal to plus 1.7, and I have asked you what could be the type, nature and size of the image and which mirror can produce this value of magnification or the type of the image which you can guess. Okay, value of MC you must have guessed, m equal to 1.7, obviously greater than 1, and when value of magnification is greater than 1, image is always larger than the object. That's clear. So dear student, guess. Image is, see, mark all this word. Positive sign means basic concept clarity. Virtual and erect. Can you guess now? Image is virtual, erect, and larger than the object. Which mirror can do this? If you can gather all mirror diagram, understand in front of you, you can guess. Concave mirror can do this. Concave mirror can produce virtual, erect, understand, and larger image of the object. Is it clear in your mind? Image is virtual, erect, and larger. Which mirror? Concave mirror. Okay. Suppose I write if m equal to plus 0.2. Can you guess? Value of magnification I have written here plus 0.2 plus and it looks less than 1 0.2. Can you guess plus virtual erect? Less than 1 means image is going to be smaller than the object. So can you guess the type of the image, nature and size of the image and the mirror which can produce this image is virtual, erect and smaller. Can you guess the mirror which produces virtual, erect and smaller image? Obviously, dear student, convex mirror. This way you need to remember here the concave only. Is it clear in your mind? This way MCQs can be generated. Suppose if I still mention one important, okay, suppose I write this way: if m equal to minus 0.7, can you guess? Because value of magnification is negative, that means negative means the direct this word needs to blink in your mind when you are conceptually stronger. Negative, real inverted, less than 1 smaller, which mirror produces real inverted and smaller image? Concave mirror. Understand? This way, dear student, MCQs can be designed. Understand? If you are conceptually stronger, nobody can stop you. This way, if m equal to, suppose I write plus minus, suppose 3.2, can you guess? Image will be, because negative, real inverted, greater than 1, that means larger. The image type is real, inverted and larger. Which mirror can produce this image? Only concave mirror. Is it clear in your mind? This way you need to be conceptually very stronger, and in today's lecture my first target was to just make you sure about the concept application regarding how they can design any MCQ and can ask you any MCQ. You need to be very, very strong regarding your basics. That's very important. Is it clear? So let's just have a sum up of the concept which you have understood. For concave mirror, focal length, never do any mistake in taking this. Focal length always negative. For convex mirror, focal length is always positive. Any mirror object distance is always negative to be taken as per Cartesian sign conventions. Image distance will give you an idea regarding position of the image and nature of the image. Plus behind the mirror, virtual and erect. Negative in front of the mirror, real and inverted. These are some of the point, dear student. Like I write, before we next session solve some of the numerical, these points you need to note down in your mind, either in your book on any margin area you need to write. concave mirror, focal length negative. Convex mirror, focal length positive. Object distance always negative. V positive behind the mirror, virtual erect. V negative in front of the mirror, real and inverted. Magnification positive, image virtual erect. Magnification negative, image real and inverted. And then, dear student, just from the given value of magnification, you can guess nature and size of the image, as well also you will get the type of the mirror utilized for that. Understand? Sometime last time also I have seen one MCQ asked in this way, that for spherical mirror value of M is minus 0.5. What can you guess about the nature of the image? The minus 0.5 means negative, means real inverted, less than 1 means smaller, and the mirror which can produce this image is concave mirror only. Okay. So, dear student, be very sure. You need to keep those image in your mind. Suppose you just list out for concave mirror. Don't go for that infinity. Just if you go start from second image away from center of curvature. What is type? Real inverted smaller. At C, real inverted same size. Between C and F, real inverted larger. Understand? At F, don't go for this. Between F and pole, the virtual erect and larger. This all image needs to be in your mind. For convex mirror, forget infinity. Just remember, when the object is nearer, you will get its virtual erect and smaller image. So these are some of the points, important, basic, needs to revolve in your mind. Concave mirror, real inverted smaller, real inverted same size, real inverted larger, virtual erect larger. Convex mirror, remember only one, virtual erect diminished image. This way you need to be conceptually very, very strong, dear student. Then and then you will get mastery in solving any example asked to you. In our next session, we are going to solve at least 8 to 6 to 8 examples regarding spherical mirror, where you will see the check of your basics again. Okay, so because our first term evaluation exam also includes this chapter, and this chapter is also again a part of your NTAC exam. So dear student, revise perfectly as a part of regular exam and also for preparation of NTSC. Okay, next session will be discussion about various examples based on spherical mirror. Okay, thank you very much.